In this section, we're going to look at graphing quadratic equations that are not in the form of the previous section. We're going to look at quadratic equations that are in standard form, ax squared plus bx plus c. And we're going to get them into the form that we graphed in the last section, which is a times a binomial squared, x minus h, that quantity squared, plus the constant k. So we're going to take this example right here and get it into this form, even though it's beginning in the standard form. And then what we're going to ask of you is to be able to find the vertex, the line of symmetry, the axis of the line of symmetry, and the maximum or the minimum point. So let's go ahead and do that. What you're going to be expected to do is take the first two terms in the quadratic equation and complete the square. So ignore the 5 for a minute. So I'm going to go ahead and write this as x squared plus 2x, and I'm going to put the minus 5 way over here. The way I completed the square, this is good practice from a previous section, is I took the coefficient of the x term, the 2, I cut it in half, and I squared that value. Well, that's a 1 squared, and so what I'm going to do now, this is different than the last time. Last time I added 1 to both sides of the equation. What I'm going to do here is I'm going to add 1 and I'm going to subtract 1. Essentially doing nothing. When you add 1 and subtract 1, you've added 0. So you've done nothing. But now what I'm going to do is I'm going to take this part of the expression and write it as a binomial squared. And it's going to be x plus 1. Remember, this is the value right here that goes in that spot. And then I'm going to collect these two terms. This minus 1 and this minus 5 gives me minus 6. And I now have this in this form, a quadratic equation in this form, where I have a coefficient in front of 1, it's just not written there, times this binomial squared minus my constant k. So what I need to do now is I need to state what my vertex is. Please remember the vertex is the opposite of this sign, so it's a minus 1, and it is the same as this sign in the y direction, or same value. So there's my vertex if I were graphing this. The line of symmetry is the line where x equals a negative 1 in this case, right here. It's the value that makes this expression equal to 0. It's where if I were graphing this in its totality, which I will ask you to do, that I would start with a negative 1 as my first value for x. And then because this has a coefficient of 1, then the graph of this problem is going to look like this. It's going to open like that. So I'm going to have a minimum for this curve. And please remember that the minimum is this value. That means, and again, I'm going to try to sketch this real quick. My vertex, I'll go ahead and put a decent graph up here. My vertex is way down here at a negative 6, and this value is a negative 1. So there's my vertex. And that is my minimum point. This is my line of symmetry. And I'm just going to throw lines going up, with no accuracy at all. But that's approximately what this graph looks like. You would have to finish with the table as well. Here's the problem that we're going to look at next. If I'm going to complete the square on this problem, however, like before, I can't have a coefficient in front of the x squared term. So before what we did is we divided both sides of the equation by 4 to make that a 1x squared. Here what we're going to do is we're going to factor a 4 out of just the first two terms. You got to be careful, it's very interesting. So I'm going to focus on these two terms right here, and I'm going to factor a 4 out. All right. And then now I'm going to work at completing the square right here. Now this happens to be the same problem as I had just a minute ago. The 2 divided by 2 is 1, and when I square that, I get 1. So my next step is going to involve adding 1 right there and subtracting 1 and keeping it in the parentheses. I am attempting to complete the square in the parentheses right now, so I got to keep that in there. Next, it is just that part right there that is called a perfect square trinomial. So that part can be written as x plus 1, that quantity squared. And I'm going to bring my 4 out in front. Here's the part that can probably get you very easily. This 4 right here needs to be multiplied by that negative 1. Because I have the 4 multiplied by all 3 of these terms, that's right here. But 4 times this negative 1 is a negative 4, plus that 1 right there will leave me with, finally, I'm completed here, 4 times x plus 1, that quantity squared, a negative 4 and a positive 1 is a minus 3. That's the equation I'm going to work with. Let me get this out of the way. In order to state my vertex, my line of symmetry, and my maximum or my minimum. So again, my vertex is the opposite of this sign for my x value, a negative 1. It is this value for my y value, a negative 3. This is my line of symmetry, x equals a negative 1. I'm looking to decide if this is a maximum or a minimum because this is a positive 4, and I'm going to try to sketch this relatively well. X is a negative 1, y is a negative 3. Let's call that the vertex. Very similar to the last problem. I see that this is going to be a minimum point, so I would state here that my minimum is a negative 3. That point right there, my output would be a negative 3. That's it. On top of it, I would like a more exact graph. I would like a table, you know, with some ordered pairs. And personally, I'm going to start with that negative 1 because that's the value that makes this 0. And I'm going to use a 0 and a 1 on one side and a negative 2 and a negative 3 on the other side and fill in those y values. But I'm looking to help you get this vertex, this line of symmetry, and this max or min. Let's graph one more problem, a quadratic equation. Here's the problem I'd like to look at. I'd like to do it again by completing the square and writing it in this form so we can state what the vertex is, the line of symmetry, and the max or the min point. Let's go ahead and remember you can only factor out of the first 2 terms. You leave that term alone all the time. And you have to factor out whatever is in front of the x squared term. So I must factor out a negative 4. I don't have any other choice. So I need an x squared here because a negative 4 times x squared is a minus 4x squared. And oddly enough, be careful with this. Now this is simple enough. A negative times a positive is a negative. I need a 7/4 x right there. Because forget about sign. 4 times 7 over 4 is 7. So that's how I got my 7/4. Next, I have to complete the square, and that's a pretty formidable task because I've got a 7/4 in front of x right here, and I'm leaving myself some room right here. So I've got to take 7/4, I've got to take half of it, remember that's how you complete the square, and then I got to square that value. Well, that value is 7/8, and 7/8 squared is 49 over 64. So that's the value I'm going to add and subtract. Remember, you add it, and then you take it away, because you want to be adding 0. You don't want to affect this problem, and then I've got to bring down my plus 2 over here. So now I can take these first 3 terms right here, because they are the part that is a perfect square trinomial, and I can write that as x plus, please remember it is this value right here, it's the b value cut in half, so 7/8 is what's in the parentheses, squared, and then the negative 4 is in front. To keep this a little clean, I'm going to get rid of this now so you don't have to look at this anymore. And then next you need to remember that this minus 4 is multiplied by that term as well, and then I'll add it to the 2. So what I have then is a minus 4, and let's do that over here, times a negative 49 over 64. So first of all, that's going to be a positive, because a negative times a negative is a positive. So let's forget about signs now. 4 goes into here once, 4 goes into here 16 times, so I have 49/16. This times this is the equivalent of 49/16. I'm going to write the number 2 as 32 over 16, because it's equal to 2. Finally, I'm in my last step of cleaning this up. And 49 and 32 adds to be 81/16. And I am ready to state my vertex. Let's go with that first. I think I might have some room over here. I'm going to state what I'm putting down, and I'll put it right below. So my vertex, remember, is the opposite of what's inside the parentheses. So that's a negative 7/8. And it's exactly what's at the end here, 81/16. So that's a challenging problem. That's where in this case, it's going to be a maximum point, because I expect this curve to go like this, because of the -4 in front. I'm just totally sketching this, so I don't have a clue if that's close. My line of symmetry is actually, if this were correct, my line of symmetry is at that -7/8, the opposite of this. So that's the line where x is equal to a -7/8. And then again, because I know the curve goes like this, I know it has a maximum point, not a minimum. And my maximum point is this 81/16. Or you can reduce it, I believe that's close to 5. So if I had really drawn this correctly, this point right here is a -7/8 and about 5 there. Again, it's not exactly, but there's my vertex, my line of symmetry, those match, my y value and my maximum match. And I have successfully given those values. I would ask you to also graph this equation accurately. This is not an accurate graph. The second objective in this section is to take a quadratic equation and to find its y-intercepts and its x-intercepts. I've got an equation up here that we're going to work. I do want to remind you that the x-intercepts are the values where it crosses the x-axis, and that's the solutions to the equation. We learned how to do that in section 1 by factoring, by graphing it and looking at the points where it crosses the x-axis, by completing the square, and by using the quadratic formula. So we learned how to solve an equation 4 different ways. And the x-intercepts were the solutions to the equation if they were real solutions, remember. So we're going to look first at the concept of a y-intercept. If you just think about, please, just think about a sketch. The point where a graph crosses the y-axis, which is the y-intercept, anywhere along that line, my x value is equal to 0. So when I'm asking you for a y-intercept, I want you to find y when x is equal to 0. So I want you to substitute 0 in here for x. So 0 squared is 0. 10 times 0 is 0. Add 21 to all of that, and you get 21. So my y-intercept is where x is 0, y is 21. If I were trying to graph this, that means, let's say these are increments of 5, then I'm right up there. Again, if this is 5, 10, 15, 20, there's my y-intercept. All right? My x-intercepts are those points where y is equal to 0, because anywhere along this x-axis, I don't care what my x values are, but y is always equal to 0 here. So this notation of f of x right there, the whole thing, I want to say, I'm going to divide this, that is 0, and it is equal to the right side, x squared plus 10x plus 21. That means I have to solve this quadratic equation for x. I've written this one, so it's fairly easy to just factor and solve and use the zero product rule. You could graph it, you could use a quadratic formula, you can complete the square, but it's awfully darn easy to solve this one by factoring. 7 times 3 is 21, and 7 plus 3 is equal to 10. And then I use the zero product rule, so I take x plus 7 and set it equal to 0, x plus 3 set it equal to 0. I state my two solutions of a -7 and a -3, and what that means, and I'm going to try to keep even increments over here, I'm going to call this a -5 and a -10. Then this x-intercept is right here, and this x-intercept is about right here, and so my vertex is somewhere down right here. Now I haven't figured that out yet, and I don't care to. What I want to know here is my y-intercepts and my x-intercepts. So I would say here that my x-intercepts are a -7, 0 and a -3, 0. Those are my intercepts. And again, if I wanted to try to get a little sketch going to this, I'd have something like that. There's where it crosses the x-axis, and there's where it crosses the y-axis. That's the second objective for this section. The section's complete. We will next look at a couple of applications, and we'll look at some modeling work where we're going to take data and write quadratic equations to fit that data. We have to have 3 points to do that, or 3 ordered pairs to do that. That's what the next section's about.